Okay, good morning. So, support tayo for our class, asynchronous online class. So, I think we have to proceed to chapter 3, which is dynamics for physics for engineers. So, first is, of course, since we don't have a face-to-face, next face-to-face would not be a class, but could be a summative 2. Of course, we already had our summative 1. Summative 2 would be coming the next meeting. So, first, of course, I usually do this in face-to-face, but since we cannot afford to have a face-to-face due to renovation, so I'll have a discussion first. So for chapter 3, dynamics, that would cover, from this book, that would cover chapter 4 and 5. These 4 and 5. So you will look at it. So medyo damo, yeah, but actually, I can summarize this into 3. Just like what I'm doing during face-to-face. I usually summarize and discusses what can you expect from those chapters. What are the problems or the concept behind for developing those chapters. So for chapter 3, following this book again, I could divide it into 3 categories. The first one is, I could say the first one is the preliminaries or the tools necessary. That is one. That is for chapter 3. Chapter 3 on our physics for engineers, but using this book, I will just be focusing on chapter 4 and chapter 5, okay? As I was saying, the book that we're using, the text that we are using. But anyway, if I summarize chapter 3, that would be 1, the tools. Tools would be, how can I say this? The preliminaries, first is the introduction of your forces as a vector quantity also. So we've already talked about motion. So for motion, you have the definition of your acceleration and velocities, both with instantaneous and average velocities and acceleration. So now another vector quantity that's being introduced is the force. But again, force with respect to the motion. That's why it is called dynamics. Kinematics would be the motion only, while for dynamics, you would be talking about the forces with respect to the motion. So that is really the meat of chapter 3, dynamics, the forces. So first is, your forces will be introduced as the resultant. That's why you have the formula here, resultant force, or the summations of forces. That's actually your resultant forces. So if that is the resultant forces, so that would be your R is just the vector quantity of your forces on X and forces on Y. That's why you have summations of forces on X is actually your X's. If you have ABC forces, or you have force A, so that would be force AX plus force BX plus force CX and so on. If how many forces are there. So that's just the summation. And then you also have summations of forces on your Y. So that would be also your summations of forces on your Y would be the forces on your A, Y. That is Y component of your force A. If you have many forces which is being involved, let's say you have a body here, and then you have a FA, then you have an FB, and then you have a force C, you have a force D. Of course, the components of these forces that would compose the components of your resultant force or the resultant. Okay? Again, the resultant is the generalized form of your vector quantities. So summations of A on Y plus summations on B on Y plus summations force on B as force of C Y, or force the Y component of C for this one. Okay, because all of this has components FCX and FCY. So of course for D and B, and likewise for A. See? So that is just revisiting your concept on vectors, but now you're applying it to force. So if you'll be looking at like that, so basically you're already in line with those. Okay, the next thing is of course introducing your forces. So what are the forces that you can expect from this? So first is you have the introduction of your weight. So weight is actually still from the second law of motion. That is the force that from your high school. Force is mass times acceleration. If there is an acceleration, so you have a force. So just like, or because you have a force, you have an acceleration acting on that body. In free, meaning there's nothing attached to it. So just like your weight, if your body is not attached to something, meaning diri ada ground, basically you have a force that will be acting on it because you are adik ka earth, labi na ka adik ka earth, diba? And that force is weight. We call it weight. And that weight is force mass times the acceleration. So we know that the acceleration on the earth is your g. It is negative 9.8. So you can always expect your weight to be going down, and this will be always going down. Your weight is always going down because as we have postulated your vector quantity, have we agreed it would be simpler or easier to view that your y-axis is going down is a negative 1. So you have weight, that's one of the forces. So another force that is being introduced here is I think one is the normal force. Normal force is we call it the contact force. Para madagmit ko yung maintindihan, I would be using it as a contact force. So if you have a body resting on a horizontal surface, you have a weight which is going down because you have a mass for this body. Let's say that's the box. You have a mass for that, so therefore you have a weight for that, and that is equal to mg. Okay, but basically for this, what is actually you know that your box should be accelerating, but if this is the case, your box is not accelerating because it is being held by the ground, let's say by the ground. So actually, in terms of force, that holding of the ground is a contact force, and we call that contact force a normal force. Normal force N. So that's why if you have a box resting on a ground and then having a free body diagram on it, because that is another tool, a free body diagram, or may I add that one? Another tool, the first one is introduction of your forces, the second one is your free body diagram. What is it? Your free body diagram is just isolating your body. That's why it's called free body. So if you have a body, or if you have a box or an object which has having a weight, actually what represents the ground is the normal force, the N. So you have a weight, and that is your N. So if this is but anyway, that is your N. If you have a tilting body, just like this, you have a box